All right, friends, let's look at another problem where we are given a set of integers and we are being given different set sizes, I say, which would range from 1 to n being the size of the array of the input. And we have to find for each set size the minimum of the maximum for a given set size. Okay. So what does it mean? So let's say if the set size is 1, so then we need to figure out what is the maximum for this given set. And then for each of the set, we find out the maximum in that given set. And when we find out the max in each, we need to get the minimum out of those, right? So for, let's say, set size of 1, the maximum, well, the maximum is going to be that element itself because there is no one else to compare with. And then we have to maintain whether it beats our current minimum, right? So let's say our current minimum is this here. We store it here. So we have 33. So we update our minimum to 33 because that's the only number we get. And then we get 11 here, right? So 33, 11. So 11 is the maximum and it beats our current minimum. So we get 11. And then for 44, it is 44. That doesn't beat our minimum. And 11 is the minimum. And so that stays as the minimum, right? So for set size of 1, the minimum is 11, right? Now let's take a look at what happens if the set size is 2, right? So for set size of 2, uh, we have 33 and 11 in one set, and then we have 11 and 44, and we have 44 and 11 again, and then we have 11 and 55, right? So we get 4 sets of size 2 each. And similarly, we have to maintain what would be the minimum, right? So what is the maximum in this set? 33, right? So we don't have any minimum, so 33 would be the minimum so far. And then the maximum out of these two is 44. We compare it with the minimum, it doesn't beat. The maximum out of these two is 44, that doesn't beat the minimum. The maximum is 55, that doesn't beat our current minimum. So the minimum is 33, right? Let's take a look at what happens when we have set size as 3, right? So 33, 11, and 44, and we get 11, 44, and 11, and then we get 44, 11, and 55, right? And we're going to do the same thing. Just we're going to iterate and see what is the minimum. So what is the maximum in this set, right? So the max in this set is 44, and we don't have a minimum, so we'll update our minimum to 44 and see if anything else comes and beats this. The max is 44, that doesn't beat our current minimum, and the max is 55, that doesn't beat our current minimum, right? So our current minimum stays 4. And we'll take 2 more examples real quick to see how the minimum value changes. So this is 33, 11, 44, and then we get 11 added, and then there will be just one more set which will be 11 and 44, 11, and 55, right? So clearly 44 is still the max here, and a minimum will be 44, and the max here is 55. So that doesn't beat our current minimum. And for the last set, pretty much it's the entire set, which is 33, 11, 44, 11, and 55, and the max value is 55, and that would be our only minimum that we can pick. So that's the 55. So you see, as the set size changes, our minimum choices also changes based on the max that we pick for a given set size. Now, uh, the intuition would be to sort of build up uh, the set size for each of the offsets and then pick the max and compare it with the minimum. So basically what that would involve is we would probably just have, like, you have a for loop for each of the set sizes, right? So you want to do it for each of the set sizes, and then you would have another for loop where for each of the offset, because you want to build, so you want to build it for each offset, right? So you build this for offset 0, this is for offset 1, this is for offset 2, this is for offset 3, and the same thing here, you did build this for offset 1 with offset 2 and offset 3, and this is for offset 0 and 1, and then you just have one offset because there's the entire set, right? So for each of the offsets you would build this set, and then for each of these you have to find out among these what is the max, right? So we'd have to go through the entire set and pick the max and then compare it with min and then the other. So picking up the max, so for each offset, right? Pick the max, right? Pick the max and compare with current min, right? With the current minimum, right? So this would somewhat become like sort of like a quadratic, a little more than quadratic time, because you would be comparing, or you would have to iterate through every set to get the max, right? So, and you would have to do this, right, for each of the sets. So uh, uh, yeah, so picking this up is involving, iterating through the sets, right? So iterating iterating through the set, right? So which would be nothing but the set size, right? So this would be times the set size, right? However many sets are there, right? So let's say if if for a set size of 1, this would be um, times 1, right? For a set size of 2, and then you have to go through. So for set size of 2 you have 4 sets, right? And each of the sets is of size 2, right? So this would be 4 times 2. And for the next one, it is for the total number of sets for set size 3 is 3, right? And then you have to go through each of the sets, right? And for the next one, similarly, you have 2 sets, and each is size 4. And for the last one, you probably have to just you have one set of size 5, so you go through that. So if you take a look at it, it's coming out to be quite close to quadratic, because each time you're ending up traversing at least 2n times of elements, right? So this is 8, this is 8, and this is 9, and this is 5 elements, right? You have to traverse through, right? So which is close to our size of the set, right? So, and each time you have to do that, right? So what would be a right intuition and an approach that we can think of here? So our problem is that we have to maintain. So the set size is sort of like a window, right? So we have to maintain a window of the set size, right? And we have to make sure that when we slide this window, because this window, if you look at it, it's sliding through each of these, right? So this is, let's say if I take this bottom example right here. So this window is currently covering these two, but then the window slides and it picks up the previous element and gets the new element, right? Every time it adds new element to this. So our window is sliding, which can be of max set size, right? Set size. And we have to have a property in this window that we can get the maximum in constant time, right? So we have to obtain the maximum in a constant time. And so one way to do that is fix the position for the constant. Let's say every time in this window, if I want to find the maximum in this window, I will look at just the front of this queue, or this window or queue. We're going to use queue. So let's say I put my max here in front of this queue, and every time I need to get the max, I'll get that. And to maintain the size, right? So if whenever I add, so how do I maintain the max in the front? So every time I add a new element, right? So let's say a new element comes in, and if the new element is greater than any element uh, than what we already have, right? Let's say let's say I have here 11, maybe 9 and maybe 8, right? So these are all in decreasing order, right? And the max is sitting here. And if I get a 12 here, right? So this 12 is going to come in and clear off whatever the elements that are smaller than it, right? So because in my queue, I always want to maintain the max at the front, right? So it will pop up this, and then my queue will only have 12. So the idea is to have a decreasing DECREA, decreasing spelling, decreasing queue, right? And to maintain the so in if we maintain a decreasing queue, then we will obviously find the max in the front, and then the queue size. So the the queue size needs to be equal to the set size at any given time, right? So let's take a look at it how it works out in the next video.